Hello, and I welcome you all to my channel, that is the Complete CSC Guide, and I am Sanskriti. Now, today I am going to start a new topic, that is guided transmission medium. It's from computer networks, right? So, before in previous classes, I have already told you about the what is transmission, right? And how the transmission medium, we have studied about the transmission modes, that is half duplex, your full duplex, and your simplex. And now today we will see how the beats are being transmitted. Now, what is about the transmission medium, about the channel, how the transmission is going on. So which medium we are just going through the different mediums, which medium is going to be used in case of the transmission. So basically you have two types of transmission medium, right? One is your guided, and one is your unguided. Where we are talking about a guided medium, I have already told you in previous classes that when we are talking about a guided one, it should be the same thing, like it is guiding, right? So it will be wired, since it is guided by something. So something is guiding the whole transmission process. At that place, we are using some kind of wires. Wire is helping us to make this transmission a guided transmission. So that transmission medium is called guided transmission medium, where we are using some wires, right? And where we are talking about an unguided transmission medium, at that time that particular transmission medium is known as unguided, which is where we are not using any kind of wires. So that is your wireless. So these are the two basic things which is to be understood in your transmission medium, right? So in today's class, we will be studying about the guided transmission medium. But before that, we have to see what is a transmission and what are the transmission mediums, right? So, first of all, you can see here, that is transmission medium. Anything that can carry information from a source to a destination, that is your transmission medium. From a source to a destination. Source where it's starting, and to the destination where it is going to be destinated, or where it is going to be arriving, where the whole bits are arriving. That is your transmission medium, right? From source to destination. Okay, so here you can see the transmission medium. Here you can see the whole thing. Here, this is in the physical layer. We are talking about the physical layer. There you have seen the transmission of beats. In the previous class, where we have studied about the OSI model layers, there you have seen that in physical layer this kind of transmission is going to be happen, right? So you can see here, this is the physical layer and this is the transmission medium in between. So this is the transmission medium. Which kind of medium we are going to use? That particular medium is here, and it is the cable of air. Here we are using this medium to just send the data from here to here. That is your sender, and here is your receiver, but it is in the physical layer itself. So this is the sender and this is the receiver. It is coming from the sender and it's going to the receiver, but in between you are having that this transmission medium. So this is what is the thing, that is your transmission medium is anything that can carry your information from the sender to your receiver in the physical layer. We are talking about here we are talking about the physical layer. So it is about the same thing. So this is the transmission medium which you can see here. Now, what are the classes of the transmission medium? Now we have understood what is the transmission medium. Now the classes. So here we have to see that I have told you already that is a guided and an unguided, right? So here you can see the transmission medium. It's of two types, guided and unguided. So guided, here you can see wired, and unguided wireless. So obviously in guided, some guidance is there, something is there which is present in between these two, that is the wire is present. So it is called a wired one. So when you are talking about a guided transmission medium, that is your wired transmission medium. But when you are talking about an unguided one, then you are talking about a wireless, right? It is about the free space. You can understand about, if you take the example of microwaves or infrared radiations, right? So these kind of things, or your radio waves, so these waves are the basic things which we understood from the wireless communication or wireless transmission medium. So these are the wireless things. And when we are talking about a wired, that means there have to be some kind of wire used. Okay, so in wired there are three categories are there. First one is your twisted pair cable. that is your twisted pair cable. There are also some forms of twisted pair cable. These are having some kind of twisted structure, right, which is used here. So some type of cable is there which is twisted in form, and that is your twisted pair cable, which is the first form of your guided, that is your guided transmission medium, which is used in the purpose of transmission. The cable which is used here, that is in a twisted form, we will see afterwards. Then next is your coaxial cable or your coax cable. So this one is also a second kind of cable, that is a wire which is used in case of your wired transmission medium. And the third one is fiber optic cable. There some kind of fiber optics is used, where the cable which is we are having there, that is using the your applications as your fiber optics. Okay, so these are basically the three kinds of your that is your guided medium, transmission medium, that is your wired transmission medium. And in case of your unguided transmission medium, that is your free space. Here we are using the space, the different radiations, the different rays, microwave radiations, the waves are being used in case of this kind of transmission medium. So here the waves are being used as the medium. So it is about the free space. Here no guided thing is there. Okay, so these are the basically two kinds of transmission medium, that's the classes of transmission medium. Is if in any question in your any examination the questions comes about your transmission medium, then you can easily write the categories of your guided and your unguided transmission medium. That now one by one we will study about the guided medias, that is the guided transmission medium. In today's class we will only study about the guided medium, and next class we will study about the unguided medium, right? That is your wireless transmission medium. So basically this is all about your wired transmission medium. So first of all, let us know about what's a guided media. When we are talking about a guided media, so what is the basic your definition of guided media? Those that provide a medium from one device to another include twisted pair cable, coaxial cable and fiber optic cable. So basically provide a medium from one device to another. So here what we are seeing, two devices, they are connected through a wire. When in wired medium we are talking about, so here we have to know that a wire is being connected from a device, that is a medium is connected from a device to another device. Since it is guided and it is being connected through a wire, that's why we are calling it as the guided media. So here three kinds are there: twisted pair cable, your coaxial cable and your fiber optic cable. So these three are the kinds of your cables which are being used. These are the kinds of wire. Why we are talking about these cables? Cables are basically made of wires. So these wires, how they are acting, so these are different kinds of wires or different kinds of cables which are being used, and each and every cable have their different tasks. Based on your work or based on your function, how you are going to use, you can use these different kinds of cables. Also they have some advantages, also they have some disadvantages also. So based on your work, what kind of transmission you want to do, what kind of data you want to transmit, you can use these basic three categories of your transmitted that is your wired transmission media. Now first thing, that is our twisted pair cable. What is the twisted pair cable? So here you can see it consists of two conductors, normally copper wire are used here. So conductors are basically here copper, right? The metal used here is the copper. So it consists of two conductors. Here you can see the drawing also. So there are two conductors, you can see at the end of these wires or the cables, you can see two conductors. So these conductors are made of copper, right? So each with its own plastic insulation twisted together. So these are the plastic insulations. Okay, so these are the plastic insulation you can see here, and they are twisted. Since the name is there, that is the twisted pair cable. So these plastic wires are being twisted. So insulation wires are being coated on them and they are twisted in form. So it consists of two conductors. There are two conductors are there. Basically two conductors are being, these two conductors, these are made of copper. The metal is copper and each with its own plastic insulation twisted together. The insulation by which it is covered, that is that is the plastic, right? Plastic material is being covered and they are being twisted with each other. So this is the main thing. And now one of the wire is used to carry signals to the receiver, that is carrying signals to the receiver, and the other is used only as a ground reference. So, the second one is your ground reference, but the first one is used to just give the, that is your carrying the signals from your sender to your receiver, and the second one is your ground reference. So these two conductors which are being used in this twisted pair cable, they, two of them have different tasks. One is for the ground reference and one is just carrying the signal from the sender to your receiver. And the wires or the conductors which are being used, they are of copper, and the insulation which is being twisted, you can see the form, twisted form. So this twisted form is of plastic, it's made of plastic and it is given a twisted form. So insulation is of plastic. Here you can see the whole figure, if you can understand from this figure, that this is the jacket, this whole thing is a jacket. If you can see the interior of that twisted pair cable, there is a jacket, okay, which is the upper portion of your twisted pair cable. Then some braided foil sheet or braided or foil sheet is there, shield is done there, which is foil sheet. So some braided shield or you can say foil shield is after this jacket, some foil shield is there, right? And after that you can see some foil shields. These foil shields, when they are coming, some you can see some wires, these are the twisted pair wires. So these are basically the cables which are twisted cables or twisted pair cables. So this is the interior structure of the whole thing. The first of all the jacket, then the braided shield, the foil shields, different foil shields are coming here, and after that which is coming, this thing which you can see here, that is this configuration, or you can see the figure. So after this what is coming is your twisted pair cable. So this is the interior structure of your cable. When you are working with this twisted pair cable, so two kinds of conductors are being used, and these conductors are basically, one is for ground reference and one is for this signal transmission from sender to receiver. It's carrying the signal from sender to your receiver. So this is basically the structure of your twisted pair cable. If you can see this structure in your question paper, you can easily understand that is a twisted pair cable, right? Now we have some kind of twisted pair cable. There are two kinds also there. So unshielded and your shielded twisted pair cable. So what is the difference between unshielded and shielded? So let's see. Most common twisted pair cable is UTP, that is unshielded twisted pair cable. That is a UTP, unshielded twisted pair cable, right? Let me write here for you. That is your UTP. UTP, unshielded twisted pair cable, right? So this is your UTP. So this is the most common kind of twisted pair cable, that is the unshielded. It is not shielded, it is unshielded twisted pair cable. And so here we can see that the structure you can see, so some shielding is there, but that is unshielded, that is UTP. It's very important. An STP cable has metal foil, that is your shielded one. UTP is your unshielded one and STP is your shielded one. What is the difference? STP cable has metal foil. You can see this metal foil, this braided foil shield, right? Braided mesh covering that encases each pair of insulated conductors. So each pair of insulated conductors, these conductors, each pair, here you can see when we are twisting something, so two kinds of wire, two kinds of conductor are being twisted. So pair of twisted pair, here is one pair, here is one pair, and here is one pair. So these are the different pairs, right? So here what is happening, STP cable has metal foil. You can see the metal foil here, metal foil shields, and metal foil sheet braided mesh covering that encases each pair of these insulated conductors. So each pair of insulated conductors are there, which is present there. So each pair, they have some braided foil, that is metal, that is your conductors are having some covering, mesh covering is there, right? So this kind of covering is not present in case of your UTP. And here this covering, you can see this covering is present there, but UTP doesn't have that covering. And this metal casing improves the quality of cable by preventing the penetration of noise or crosstalk. It is bulkier or more expensive. So it is mainly why we are using this metal covering, so that it can improve the quality of your cable. It will help reduce the penetration of noise. When it is helping reducing the penetration of noise or your crosstalk, obviously you can understand this kind of thing we are using in telephone, that is your cross talking is there. Sometimes we are talking with some person, some cross talking, cross connection is there. So this kind of penetration of noise is being just it is diminished or it is decreased by this kind of UTP, that is your twisted STP, that is a shielded twisted pair cable, right? This shield helps us to reduce that penetration. If the noise penetration is more, then obviously crosstalk is more. If the noise penetration is less, then these cases of crosstalk will be also less. So this shield is usually used so that we can decrease the penetration of noise or your crosstalk, and obviously it will improve the quality of your cable. Since your crosstalk or your noise penetration is less, obviously your quality of the cable will be more, it will be good enough, right? And it, since it's bulkier, where you can see that how many layers are there, so obviously it is bulkier in nature. Since it is bulkier in nature and we are using so many insulations, we are using so many wires and insulations are there, metal insulation is there, also it's bulk in nature, so obviously it is expensive also. It's a disadvantage that it's very expensive, right? It is more expensive. Common UTP means where you can see RJ45, it's a common UTP name, that is your RJ45. Okay, this one is called RJ, means registered jack. Okay, so this is the registered jack, which is the RJ45. It is the most common type of your UTP, that is unshielded twisted pair cable. Now you can understand from this thing that when we are twisting this thing, each and every time we are having two pair of that's one pair of your cable, that is two cables are present, two conductors are present, which you are twisting, right? And here this shielding is very much important to improve the quality of your wire or quality of your cable. So this kind of metal shielding or this kind of shielding is done so that to improve the quality. So in case of this STP, this quality is being improved, the cable quality is more improved. This particular insulation is done and it is reducing the penetration of noise as well as your crosstalk. But since it is bulkier in nature, so many insulations are done, so many layers you can see here up to the conductors. When you are coming up to the conductors, some layers you can see here. So obviously it is more bulkier in nature. When it is bulkier in nature, it is expensive also. RJ45 is a common type of your UTP. So it is registered jack. RJ means registered jack. So this is the common type of UTP which is being used nowadays. So this is what is there in case of your twisted pair cable. Now what is the advantages of using this? So basically UTP is cheaper. When we are using UTP, STP is obviously expensive since it's bulkier, so it is more expensive. UTP is cheaper than STP, and installation of UTP is very easy. When you are going to install the UTP, it's very basic kind of cable. So the installation process of your UTP, that is unshielded twisted pair cable, is very easy in nature. It is not so much complicated. So UTP is more used in day to day whenever we are using. So you can see the applications also. And here we are, first of all, let's see the applications so you can understand. Applications are telephone to provide voice and data channels. We are using in the telephone network to provide the voice as well as your data channels. So in telephone network, this kind of your UTP or STP is being used. And local area network, that is 10 base T and 100 base T, also use twisted pair cable. So here also twisted pair cable is used for your local area network, right? That is your LAN cable connection. And it is why we are using, it is cheaper in nature. that is your UTP is cheaper. Installation of UTP is very easy, since you can install UTP in a very easier manner. So it is used in telephone networks. Since the telephone networks, you can see the how the wires that they are connected, so the nature should be very easy to be installed. Since it is used in, we are using the telephone in day-to-day life, as well as the crosstalk should be minimized, so you are having some advantages. Also, it is easy to be used. And the last one, used for high speed LAN. For high speed LAN connection, also this kind of twisted pair cables are being used, that is your UTP and STP. Disadvantage, it is used for shorter distance. Due to attenuation problem, it is used for shorter distance only. You cannot use this for a longer distance purpose. So this is basically the disadvantage of your that is your UTP, that twisted pair cable. So twisted pair cable, the UTP, it is very cheaper and very easier to install. It is cheaper than your STP, which is bulkier, and it's more expensive than your UTP, right? And it is used for your telephone connection and high speed LAN, that is LAN connection, local area network connection. So this is what is basically there in your unshielded and your shielded, that is your twisted pair cable, right? Now next one is about the coaxial cable. So first kind, I think it's clear. Next thing is your coaxial cable. You can call the coaxial cable as coax cable also. We call it as a coax cable also, right? So it carries signal of higher frequency ranges than those in twisted pair cable. So here the signal which is being transmitted is of higher speed, or it is of the higher frequency which is being used here. Higher than what? Than twisted pair cable, right? So here what is the signal, whatever signal is being carried, that is of higher frequency than in your UTP or STP, that is your twisted pair cable, right? Now it has a central core conductor of solid or stranded wire, usually copper, enclosed in an insulated sheet, which in turn encased in an outer conductor of metal, foil braided combination or combination of two. Here also you can see the whole picture, that is this one is the plastic cover, first plastic cover, right? After that you can see the insulator. So there are two insulators used, first one is this one and second one is this one. In between there is a outer conductor shield is used, right? So after plastic cover, some insulator is there. After that insulation, you can see a outer conductor shield is there, okay? Some shielded wire is there. Then again some insulator is present. After that insulator, this inner conductor, you can see the inner conductor. So here one inner conductor is there. There we have two inner conductors. Here you can see one inner conductor is there. So it has a central core, a conductor of solid. So solid stranded wire, usually copper, enclosed in an insulated shield. This one is the inner core conductor. So insulated shield is there, right? And this insulated shield, which in turn is encased in an outer conductor shield. This one is the outer conductor shield. And after this one outer conductor shield is of some metal, foil or braided or combination of the two. Then this outer metallic is wrapped both as shield against noise and second conductor which completes the circuit. So this second conductor is used for completing the circuit. And this conductor, this one, the outer metallic wrapping which is used here, that is used for shield as well against the noise which is being used. So we are using this sheet. Why you are using? So that it is protecting that particular conductor from the noise. Okay, so here you can see how many layers are there. First the inner conductor, that is your core conductor. So this one is your core conductor, right? And after that some insulation is being done, and this core conductor is also made of copper. Copper wire is used here, right? And after that some solid and stranded or braided wires are used, and this is made of copper. Then some insulated shield is there, which is insulated. You can see two insulators, one is here and one is here. So it is the insulated shield is used here, right? And it is having some outer conductor of metal. This is the outer conductor shield. This one, this thing. Again some insulator is there, and after that some plastic covering is been done. Why this insulated shield is there? So that it can protect the whole cable from noise. And the second one, that is two, you can see the combination of two, right? So outer metallic shield against the noise, it's making a shield against the noise. And the second conductor which completes the whole circuit, right? So the outer conductor is also enclosed in an insulator shield, and the whole cable is protected by a plastic cover, this cover. So here so many layers are there. You can see that so many layers have been used here. So the outer conductor, mainly this one is the the outer is here. The outer conductor is also having this shield is being protected. Lastly, the whole cable is being protected by this a plastic cover. So this is the main thing. So the most common, this is the conductor connector which we use today. This kind of connector, that is your Bayonne concealment. Okay, BNE connector. This is the main connector which we use in today. That is your coaxial cable. What is that? That is BNE. Right? That is your Bayonne Neal concealment. So this is the basic connector we use in today's life. And this thing you can see that how many layers are there to protect the particular inner core. And this inner conductor and this outer conductor, there are two kinds of conductor used here, and obviously every conductor is being again covered by a insulator, right? And lastly, the whole wire is being covered by a plastic cover. And these conductors, why they are used, so you can see here the outer conductor of metal or combination of two, so it serves both as shield against noise, and the second conductor completes the whole circuit. So it is just protecting the whole cable from the noise. Basically what is happening whenever you are transmitting something, the main thing which comes is the noise, which is creating the whole problem. So there are shield or sheet which is used to insulate the whole wire, to protect the whole wire from this noise purpose. If noise is there, obviously crosstalk will be there, and obviously your whole thing will be, the whole whatever thing you are transmitting, some disturbance will be created. To just reduce that disturbance, we have to reduce the noise which is coming inside these cables. To reduce that noise, this particular insulation is done. The how much the insulation you are using, that much noise will be reduced. So here also you have seen that how many braideds have been done, how many insulations have been done, and here you can see. But here what is happening, we are having two copper, that is your conductors, which are being used here, right? But here you can see that two conductors are used with some insulator, which is being enclosed in some insulator. So here you can see this is the central core and this is the conductor, and this, that is your central conductor or center core, and your outer conductor shield is there. So these all thing, the whole thing is also being protected by a plastic cover. So this thing is obviously giving you more higher frequency transmission than your UTP or STP. Again, advantage here is the high speed. Since you can see here the how the conductors are being enclosed in insulators and how they have been protected from noise, the speed here is very high. The transmission speed is very high. Okay, and the bandwidth of this particular thing is also higher. Whatever transmission we are doing, the bandwidth is also higher than your UTP and STP. And better shielding is provided. Here the shielding, whatever shielding was provided, but it was your braided folded sheet, but you can see here only no insulator having used, only folded shield are being used for insulating that one, right? But in this case you can see that two conductors are there, the core conductor and your outer conductor, and the insulator are used here, and also a plastic covering is used. So here shielding is better than your UTP and STP, that is twisted pair cable. But the shielding in your coax cable, that is your coaxial cable, is better. So your speed is higher, your bandwidth is higher, the transmission bandwidth, as well as your shielding is also better. But also some disadvantages there, that is expensive. It is very much expensive. Since shielding is more, so obviously it is very much expensive than your UTP and STP. And the second thing, if any kind of fault occurs, in case of whenever you are using this kind of coax cable, if any kind of fault occurs within the wire, then whole system will be having a fault. The total system will be failure. So whole network will be having a failure. So any fault if occurs, then the whole network will have a fault occurred. Okay, so this is the basic whatever disadvantage of your coax cable, which is not present in your twisted pair cable. Now, how we are using this one in analog telephone networks, this kind of coax cable is used in your digital telephone networks, in your cable TV networks, as well as your Ethernet LAN. When you are using the Ethernet LAN, there also this kind of coax cable are being used. So this is basically what is there in your coax cable, right? So the main thing which is there in your coax cable is the shielding. The shielding is very much important here, and it is better than your twisted pair cable. Then now next thing, what is the third one is your fiber optic cable. Now what is about a fiber optic cable? Cable that uses electric signals for communication. Here basically electric signals are being used for the purpose of communication. So electric signals are used here for your communication purpose in case of your fiber optic cable. And here obviously you can understand some kind of fiber is used here. Fiber optics, the whatever things we have studied in the fiber optics in your science classes, that you can understand here that that kind of applications are with the that kind of applications, this fiber optics, whatever we have studied in that fiber optics, you can understand that those applications have been used in case of these fiber optic cables, right? So whatever advantages, whatever disadvantages were there in case of that fiber optics, that thing you will get here also. So those applications have been used in case of this fiber optic cable, right? So first one is your electric signals are used for communication. Next, cable that holds the optical fiber coated in plastic that are used to send the data by pulses of light. So here the cable holds, here also you can see the picture. So the cable here holds the optical fibers. Some optical fibers are used here, right? Which are coated in some plastic that is used to send data by pulses of light. Here, since fiber optics, we are dealing with some light also. So here you can see that a plastic jacket is used here. Again some plastic jacket is there. After that some cladding glass is used. Okay, since we are dealing with the light, so some cladding glass is being used. And here the core glass is present. This one is the core glass which is in middle. This is the core glass, right? So this is here what is the picture of your fiber optical cable. So the first one is your jacket, plastic jacket. Inner side is your cladding glass is present there. Since some kind of you are working with some kind of your light, so some reflection is there, some reflecting agents are there. So here we are using some kind of cladding glass, and after that you can see the core glass which is in last one. That is, here we have seen the core conductor, and here it is the core glass material is being used. So this is here mainly the fiber optics is being coated. Some fiber opticals are there which are being coated by this plastic covering. Again, plastic coating protects the optical fibers from heat, cold and electromagnetic interference from other types of wiring. So why this kind of plastic covering coating is used? This plastic coating is used for these kind of things so that it can protect the whole wire optical fibers from heat. It is very much important. Since you are using the optical fibers, you have to protect that from heat, you have to protect them from cold, and the main thing is your electromagnetic interference of the other wirings. Since so many wirings are there, so some electromagnetic interference is being created there which can disturb your transmission process. So this kind of plastic covering is used here, which is just making your whatever cable is there, it is protecting your cables fiber optics from heat and cold, as well as the electromagnetic interference which is being created by the other wires which are going in from a side of this particular wire, right? So this kind of cladding glass is used, core glass is there, and this plastic jacket is very much important in case of your fiber optical wire, right? And now, since you know everything about this, now the main thing is faster data transmission than copper wires. Here, why we are using this fiber optical wires? Since this fiber optics is giving you a higher transmission. The speed is very high in case of if you are using this copper wires in your twisted pair cable or your coax wire, it is giving you a more higher speed when you are using the fiber optics. Okay, so these particular faster data transmission than your copper wires. So optical fibers are giving you more higher speed than your copper wires. So obviously the fiber optic cables have been used more than this kind of your coax cable or your twisted pair cable. Now here you can see a particular thing, that is how this cladding is done, right? How this kind of cladding is done. So here you can see a particular box, right? So here is your sender, this one is your sender, this one is your receiver. In between, what is happening here, how this thing, why this cladding is done. So here two particular covering of cladding is done, that is your cladding glass, right? What this is doing, these are the two claddings which have been used, and we are having a core, that is your core, this core glass. How did this, whatever thing is being coming here, so that is in the reflected pattern. So here you can see the pattern will be like this. So what is happening here, in between these two cladding glasses there is a inner core glass. So basically this thing is happening, this inner core glass is there and two cladding glasses are there which is enclosing this inner core glass, and this is the sender and receiver in between whatever things are being transmitted. So this is what is happening, this thing what you can see here, the plastic jack, this one is the plastic one, plastic jacket. After that you can see the particular core, your cladding glass is there, right? This one is the cladding glass, and the last one is your core glass, this one. So how this thing is happening, this particular thing is like this, the cladding glasses are there in two phases, and in between that particular thing the core glass is there. So this is basically, the structure is like this, right? It is the interior structure of your optical fiber. And now this is what is happening here, the basic elements which are used in this optical fibers are three kinds of things, that is your core, cladding and your jacket, the outer thing. So the core is there, cladding is there and your jacket. This is the core, this is the cladding, and above that is your jacket which is protecting the whole optical fibers. So what is the function of this core, cladding and your jacket? So let's see. So basically the electric signals are going through this particular thing, right? And this is being transmitted. So whatever reflection is going on, in you have seen here we are using the pulses of light. So whatever reflection is going on, that particular thing, to make that thing we are using this kind of cladding, and in between there is a core. So these cladding glasses are being used, right? Now what is the basic element? So core, narrow strand of glass or your plastic. So basically this core is the narrow strand of it, it can be of glass or your plastic. So it is a narrow strand, you can see this very narrow strand is there, that is of glass or your plastic, right? So here light transmission area of fiber. So this is basically the portion where the light transmission is happening. So here the light transmission is going on, whatever light transmission is going on, that is through your core. So here this cladding is done for the reflection purpose, but here the light transmission is going on through this core only, right? So what you can understand, that more area of your core, the more area of your core, right? More area of core, then what will happen? More light transmitted in fiber. So how much the area of your core, how much the light will be transmitted in the fiber, that will depend on the area of your core. If the area of your core is more, then obviously the light what is transmitted inside the fiber, that will be more. And if your area of the core is less, then obviously the light what is transmitted inside the fiber, that will be less. So Basically, this core area is very important in case of your fiber optics, since the light transmission is only happening in this core area, nothing else. Other things are for reflection purpose and for your protection purpose. But this main thing is your core area in case of your optical fiber. And this transmission of light, when it is happening here, so obviously whatever, if the whatever your core portion, if it is more, then obviously the whatever transmission is going on, that transmission, light transmission to the fiber will be more. If the core area is less or smaller, then your light transmission will be lesser. So this is what is there in case of your core material. Then now next we are going for your cladding, that is this area, this particular area. This is the cladding area, this is the core area. Main transmission area in optical fibers is your core. Then we are going to the cladding, that is concentric layer of glasses. Here concentric layer of glasses are there. Cladding a concentric layer of glasses, right? So these are the concentric layer of two glasses. Now what is happening? Main function is to provide the lower refractive index at the core interface as to cause the reflection within the core, so that light waves are transmitted through the fiber. So I have told you that when you are using the optical fiber, some case of reflection and refraction is there. You know that one, right? Now what is happening there? The main function, the lower refractive index at the core interface. The core interface should have a lower refractive index. Then why it is having a lower refractive index? So that the cause, it will as to cause the reflection within the core. The reflection, you can see here how the reflection is going on. So reflection within the core, the light waves are transmitted through the fiber. So to make the reflection correctly and to make the transmission of light correctly, these claddings are used. It is having some lower refractive index, which is making the reflection within the core in such a way so that the transmission of light is going on correctly within the core. Since the transmission is going on within the core and the reflection should be done correctly, so this cladding is used, right? These are concentric layer of your glasses. Done. And now, so these particular things, the transmission is done, and to help that transmission, lower refractive index is there in these claddings, which are helping the cause of reflection within the core. You can see how the light is being reflected here. These are the lights which are reflecting here in this manner. So to help this reflection of light, this cladding is used. These concentric threadings are used. Now the last one is your jacket. That is the last one here, the plastic jacket. Why it is used? So here the jacket is the protective coating of plastic. This one is for the protection purpose, right? So this one is for your transmission purpose. Core is for your transmission purpose, right? So here core is for transmission of light, right? Next is cladding, which are helpful in reflection within the core, which is helpful in your transmission. And last one is your jacket. Why this jacket is used? This jacket is used as a protective coating, right? Coating of plastic. This is basically first one, your core is can be of plastic or can be of glass, and next one is cladding, which is used of glass, and the last one is of plastic, that is your jacket. That is a protective coating which is used to protect the whole particular your optical fiber. Why it is used? So that it can help protect these optical fibers from the electromagnetic heat and cold obviously, but from the electromagnetic interference which is occurring due to the other wires which are present there, other wiring which is present in the system. So from this other wiring, some electromagnetic interference is there to protect our cable, optical cable, from that electromagnetic interference. this kind of jacket is being used. It's a protective coating of plastic. Again, main purpose of this is for preserve fiber strength. The fiber strength is being preserved due to this jacket, plastic jacket, and it absorbs some shock. If any kind of shock is there, it absorbs that particular shock, and extra fiber protection is being provided. Obviously, extra fiber protection is very much needed when we are working with this kind of optical fiber. We are working here with the some light, some kind of light. So here extra fiber protection is very much needed, which is being provided by this jacket, plastic jacket, right? Now, next thing is about advantage. What is the advantage of our particular this fiber optics? Why we are using the fiber optics? Done. So here it is having a greater bandwidth. We have seen that here whatever the bandwidth was there in twisted pair cable, here the bandwidth was greater in coax cable. But when you are using this fiber optics, the bandwidth is more greater, is greater than this twisted pair cable or your coax cable. So here the bandwidth is more, right? And after that, greater immunity. Here also less signal attenuation. Since we are working with some kind of light, the signal electrical signals are used here. So signal attenuation is lesser than this UTP, STP or your coax cable, and it is having immunity to electromagnetic interference also. This thing is being provided in the fiber optics only. That is, it's providing you some protection from the electromagnetic interference. And here greater immunity to tapping. Here it is providing you greater immunity from tapping also. So these are the basic advantages of your optical fibers, that is your fiber optics when you are using here. And disadvantage is having some disadvantage, that is requires expertise for installation and maintenance. Since fiber optics, you can see here that what kind of how we are using the cladding of glass. You have to deal with the fiber optics, you have to deal with the optical fibers. So here you can see you are dealing with so many things. So obviously you have to understand that here the installation should have some expertise, can only provide this kind of installation. So the installation in case of your UTP was very simpler, but here in case of your fiber optics, the installation, whatever installation is being done, that installation needs some expertise to be installed correctly. Obviously not only your installation, but also the maintenance of these wires are very important. Each and every time it should be maintained in a proper way. Obviously the maintenance of these kind of wires, that is your twisted pair cable or your coax cable, it is very much easier in case of, since these are using some copper wires, but here you are using some glasses, right? The cladding glasses are there, the inner core is also made of glass. So here the maintenance is should be provided very nicely. So also expertise in your installation case as well as maintenance service should be provided very nicely. So it is the main disadvantage. Since these things are made of glasses, it's very you have to, these are brittle in nature also, so you have to deal with them in a proper way. And next is your unidirectional light propagation. Here the light propagation is unidirectional in nature. In case of here, you can see whatever light it is coming, you cannot receive a light in a against this particular face, right? So you have to see that the light should be unidirectional in nature, right? So the light should be unidirectional in nature. Here the light whatever is transmitted, that is only in one direction, it's not bidirectional, it is unidirectional in nature. And it is obviously of a very higher cost. Since you are using the fiber optics fiber, the main disadvantage in fiber optics is of a very higher cost. It is more expensive than these two. Since you are using the copper cables only, copper cables are being used, they are not of so much cost. But these fiber optics, they are using some kind of cladding glasses, they are using some kind of core glasses, and the protection is also there, the maintenance is there, the installation is there. Obviously it is of very higher cost than your these two things. So now you have a knowledge of the wired guided, that is your guided transmission medium. First one is your twisted pair cable, where your UTP and your STP, that is your unshielded twisted pair cable, and your shielded twisted pair cable is there. You can see the structure that two conductors are being twisted and they are being insulated by some plastic, and the conductors are obviously of copper wires. In coax cable also you can see a structure. There are two conductors, the inner and the outer, and some insulators are there, and a plastic covering is there to protect that thing, and that is more better than your twisted pair cable, right? And this fiber optics, that is the third one, is using the basically it's using the applications of light, that is your refraction and reflection, and by using those phenomenons we are using these fiber optic cables, right? So your fiber optic cables are also very nice, but they are expensive in nature. They are providing you better quality, they are providing you protection from electromagnetic interference also, they are providing you protection from heat, cold, everything, as well as they are also giving you a very much strength of your transmission, and they are giving you a greater bandwidth, less signal attenuation is there, and immunity to electromagnetic interference, and immunity to tapping also. But they are very expensive in nature, and the installation and maintenance is very much very heavier than your whatever, it's very complicated than your other things. Now this is what is there in your particular this guided medium. Now one thing which is very important, that is propagation mode of your fiber optics. Okay, this thing few people they told about this thing, but it is also a very important topic. I thought that I should tell you about this one, so I am telling you in a very brief manner, right? So propagation mode of your fiber optics, these fiber optics are there, but whatever things we are propagating, there are some modes of propagation, right? So this is the mode, one is multi-mode and one is your single mode. In case of multi-mode, you can see the step index and graded index is there. Now, multi-mode is there, multiple beams from a light source move through the core in different paths. So, you can see the multiple beams of light are coming, right? So, multiple beams from a light source, okay, move through the core in different paths. So, move through this core. This is the main core. So, multiple beams of light can move through this core in different paths. So we are calling it as our multi-mode of the propagation of your fiber optics, right? Or your fiber optic. And next one is your single mode. This uses step index fiber and highly focused source of light. Step index fiber is being used there. Some kind of fiber is there, that is your step index fiber, and this single mode uses this kind of step index fiber, right? And these are basically, okay, you can understand that this single mode, whatever this single mode, it is using some step index fiber, step index fiber, okay, and highly focused source of light, and highly focused source of light, right? So these things are being used within this one, and that limits beam to a small ranges of angles. Why we are using this thing? These are limiting these beams to a single source, okay? Single source of angles are there, single small ranges. It is making the ranges very small. In multimode, so many multiple beams are coming and they are going to different directions. But in single mode, we are using a step index fiber and a highly focused source of light which is being used. Highly focused means it is just focusing the all whatever beam is coming, is focusing it into a particular point. So these two things are being used, step index fiber and this one, so that this particular whatever light is coming, that limits beams to a small ranges of angles all close to the horizontal, so that this horizontal, this whatever light is coming, that is sourced to a particular angle in such a way that is coming to a particular point, right? So these kind of things are used in propagation of your fiber optics. One is your multi-mode and one is your single mode. Multi-mode, many beams are coming here, many beams are coming and they are going to different directions. But in single mode, when we are using the simple index fiber, as well as highly focused source of light is being used, so that the particular source of light does all that is for all that is close to the horizontal, whatever thing is coming, it is focused to a particular point. So this is what is there in your propagation of fiber optics. So this is the thing. If any question comes from the propagation of fiber optics, so obviously you can write something about this, right? So this is basically the propagation mode. Now in next class we will study about this thing, that is the, here we have to I have told you also that about the wireless communication. So your transmission media, there will be something like this, that is the wireless. This was the guided one, okay, transmission media. Here that there will be three things. One will be microwave, infrared radiation, and microwave and infrared radiation will be there, which we will study in the next class. Okay, so these are the basic thing which we used in your kind of your wireless communication. And the third one is your radio waves. So these are basically used in case of wireless transmission. And in wired transmission, what you have seen, so now when you know everything about your wired transmission, now you can understand that why we are calling it as a wired transmission. Since each and everything you have used, we are using some guided transmission, that is some kind of wires are being, some kind of cables are being used. In twisted pair cable also you have seen some kind of wires we are using. In coax cable also you have seen some kind of wires we are using. Obviously that particular wires were of copper. And in fiber optics you have seen that some kind of glasses are used, but there also some kind of transmission media is there, that is your that is your glass in nature, or plastic or glass in nature, the core conductor, that is the basic thing. Okay, so here you can see guided, but when we are talking about the unguided media, at that time you will have no wire, there will be no wire. Here you are having a sender and you are having a receiver, but in between you can see that some wire, some kind of wired transmission is there. But in case of your unwired, that is your uh, unwired connection, wireless connection, there in between this sender and your receiver, what will happen, there will be free space. Okay, you can understand that when you are using the free space and no guidance is there, obviously the waves which is there in the atmosphere, that waves are taken into account. There may be the microwaves, there can be the infrared radiations, the waves, the radiations. These are the basic things when we are dealing with this kind of wireless communication. So there the waves are important, the radiations are important. So three kinds of thing we will study, that will be our microwaves, that will be your infrared radiations, and your radio waves. These three are used in all our things, that is our radio signals we have seen there we use, and how we will be using these things, that we will discuss in your next class. And here whatever thing in this class we have studied, this is all things about your guided medium, right, guided transmission medium. There in next class what we will study, that will be about your unguided transmission medium. So till then, whatever you have studied, if you have any kind of doubt, any kind of queries related to this, you can easily ask me in the comment section. And if you have any kind of suggestions related to these particular videos what I have shared you till now, you can give me those suggestions also. If you want to know something about any other subjects, not only this networking, we will not discuss about networking only. I have already told you that in these classes we will study about other topics also from different subjects of our BTech in CSC or your IT. So you can ask me that also, you can give me suggestions related to those topics we can discuss here. And these things are basically for your exam purposes only. We are not going to a whole subject. We are just getting those topics which are very much important to your exam purposes, very much important, right? And if you have any, so if you have any kind of suggestions, if you want to know any kind of subjects or any kind of topics of any subjects of our CSC topics, then you can ask me that particular thing in the comment section so that I can know your suggestions, right? And if you like my channel, then please like and subscribe my channel to your, you can share my channel to your friends or relatives so that they can also have some education, have some knowledge from my channel, right? Till then, take care and goodbye.